As we study geometry concepts related to trigonometry, like law of sines, law of cosines, those were with triangles, we're going to talk about another geometric object called a vector. Maybe you've seen these before, maybe you haven't, but a vector is a very particular mathematical object, and to help us understand what a vector is, we're going to have Vector from Despicable Me to help us understand what it is.
Hey, I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
And there we go. So vector has told us that mathematically we represent a vector with an arrow and it has a particular magnitude and direction. Okay, and so more specifically when we work with vector quantities, they're hard to come by sometimes in the physical realm, but we do see scalar objects all the time. Scalar quantities have just a magnitude. And so if you're thinking like what are some examples of scalar quantities versus vector quantities, one everyday example of a scalar quantity is speed. Okay, so if you are driving in your car, you're looking at the speedometer, that's telling your speed, your change in distance over change in time at a particular moment in time. If we were to look at a similar related quantity that is a vector, so we would need an amount, right? That's what a magnitude is, it's an amount, and a direction. The corresponding concept there is velocity. And let me just write these a little bit differently. So speed, and then the vector quantity that is associated to it would be called velocity when we take the direction into consideration. Okay. On that same note of speed and all that, if we look at just distance, like how far it is from place A to place B, that's a distance. But if we talk about it's a distance in a particular direction, that is called displacement. Okay. And I'm sure you can think of other measurements that just have a number associated to them. If they have just a number only, then it's a scalar quantity. If it has both a number and a direction in order to define it, that's when we talk about it as a vector quantity. Okay. Now, that's a basic idea of vector versus scalar. But in addition, vector from the Despicable Me video that we watched talks about vector being defined geometrically as an arrow. Okay, well, mathematically we can define it a little bit more precisely than that. But yes, it is going to be an arrow. Okay, I would call it a ray. As a mathematician, I would call it a ray, and it would begin at a point P and end at a point Q. Okay, so it is indicating you go from P to Q. Okay, now how, and then we would give it a name. We would call it vector V. Okay, and we symbolize a vector with an arrow on top of it in a one direction in one direction. Just so we're clear, if we wrote V versus V and had the arrow going the other way, these things are not the same. Okay, that's indicating a different direction. Okay, just a little word of caution. Okay, in this geometric construct, okay, P has a particular name. We call this the initial point, where it begins, initial, right? And Q would then be where it ends. We would call that the terminal point. Okay, so initial and terminal are super important because that indicates the direction. So make sure to get these concepts, that piece of language in particular, down. Okay, now vector said, okay, it's an arrow that has a magnitude and direction. How much is the magnitude? Well, the magnitude is just going to be how much space it is from P to Q. Okay, in this context, if we say we're going from P to Q, maybe we're thinking about distance, so magnitude could just be a distance. Okay, as soon as we indicate a direction, and direction, we typically think of direction as being calculated from the initial point. So we imagine a little tiny coordinate grid where P, our initial point, is at the origin, okay? And then we imagine extending axes out from there, okay? The angle or the direction that we calculate the vector is with respect to standard position. So we would imagine starting at the positive x-axis for angle measurement, right, like any other angle, and then we would rotate up until we hit the vector. And this we would represent as theta, and this would be our direction. Okay. So yes, vectors are quantity with magnitude and direction. We now have some additional language associated to vectors, and we can talk about what their magnitude and directions look like geometrically. So that's just a quick introduction to vectors. We'll discover more properties of them in the upcoming videos.